Compute each limit and draw a diagram to illustrate. So example part A is the limit as x approaches 0 of the absolute value of x over x. Now, we know that we can separate this, any absolute values, into piecewise functions, so that's going to be helpful for us to think about. So I know that the absolute value of x can be thought of as two different functions. So one when x is greater than or equal to 0, and one when x is less than 0. So if x is greater than or equal to 0, it's just going to be x. Nothing is going to change for that. But when x is less than 0, the absolute value is going to be considered a negative x, right? So that's important for us to think about. And so if we want to think about what now happens to the limit as x approaches 0 for the absolute value of x over x, we can think about what is that going to look like. So if I have the absolute value of x over x, well, then this is going to be, again, I'm going to have two criteria, one when x is greater than 0, and one when x is less than 0. You'll notice that I don't include 0 this time because I can't have the denominator be 0, so that's going to be a restriction in terms of that. So, but if I think about what are numbers that are greater than 0, well, then my function is going to be x divided by x, which would just be 1. And the function, if it's less than 0, is going to be negative x divided by x, which is just negative 1. So those are really the criteria that I'm looking for this piecewise function. So now we're going to take a look at the limit as x approaches 0 from the left side of my absolute value of x over x, and the limit as x approaches 0 from the right side of my absolute value of x over x. So if I've already worked out this piecewise function here, so if x is approaching 0 from the left-hand side, then that means we're looking at values that are less than 0, then the limit is going to be negative 1. And if I have values approaching 0 from the right-hand side, they're going to be positive, and so the limit of that is also going to be 1. And so we know that we can see that the limit from approaching the left side does not equal the limit that approaches from the right-hand side. Therefore, the limit does not exist. So we can say that the limit as x approaches 0 of the square root of x over x does not exist. And so what is this graph going to look like? Well, if I draw a quick sketch here of my Cartesian plane, my x and my y, when x is less than 0, it approaches negative 1. So I'm going to have an open hole at negative 1 and then a straight line going towards the left. And for the values that are going to be greater than 1 or greater than 0, it's going to be at positive 1. I'm going to draw an open circle there. And there's going to be a straight line going towards the right. So that's what this function would look like. And that's why we can see that the limit doesn't exist, because the function as it approaches from the left side is not going to be the same value as the function as it approaches from the right side. Let's take a look at another absolute value function. So here I have the limit as x approaches 0 of x times the absolute value of x. Now, same thing, I want to think about what is happening to the absolute value function. So the absolute value function is really, if we think about what it looks like this, right, on a Cartesian plane. This is your absolute value function. So when x is greater than or equal to 0, it's just going to be our x values. And when x is less than or equal to 0, or less than, just less than, we're going to have negative x values. And so what I want to think about now is what happens when I go ahead and multiply an x by that. Well, this piecewise function is going to be for x is greater than 0, or greater than or equal to 0 in this case. We don't have to worry about any restrictions. It's going to be x times x, which is x squared. And when x is less than 0, it's going to be negative x times x, which is going to be negative x squared. And so these are the two functions that we're going to look at when we're trying to find the limit as x approaches 0. So we're going to do x approaches 0 from the left side of x times the absolute value of x. And we're going to do as x approaches 0 from the right side of x times the absolute value of x. So if I think about this, if as x approaches 0 from the right side, it's going to be like 2 times 2, which is 4, and then 1 times 1, which is 1, and then 0 times 0, which is 0. So I can see that the closer, as I get closer and closer and closer to this, I'm going to get to 0. And then if I wanted to think about what is happening on the right-hand side, the same sort of thing, right? I can think about this being, these functions as being a parabola, right? So this is a parabola that opens up, and this is a parabola that opens down. And my parabola that opens down, if I wanted to sketch that first to see what it would look like, I can go ahead and do that if that helps you figure out what the limit is. So as x approaches x from the positive side, it's a parabola that opens up. And as x approaches 0 from the negative side or from the left-hand side, it's going to be a parabola that opens down. And so that's the information that I can glean from this piecewise function here. So I can see from the function that yes, as x approaches 0 from the left-hand side, it's going to be 0, and as x approaches 0 from the right-hand side, it's also going to be 0. And so because the limit of the left-hand side equals the limit from the right-hand side, we can say that the limit as x approaches 0 of my function x times the square root of x is going to be 0. Let's do one more absolute value function. So let's take a look at the limit as x approaches 0 of x squared divided by x. So again, what do we have here? So the absolute value of x is really, we're just taking a look at what is happening to my function, right? I already know that the absolute value function is that piecewise function where it's going to be x when x is greater than or equal to 0 and negative x when x is less than 0. So what happens when we're taking x squared and dividing it by the absolute value of x? So we're going to get a positive value, a positive x squared divided by an x squared, which would just give us an x. That's when x is greater than 0. Now again, I have a fraction, so I can't have it equal to 0 at the bottom. So it's just going to be greater than or less than 0. And as x approaches 0 from the left-hand side, or when x is less than 0, I'm going to have x squared divided by negative x, which is negative x. So those are my two piecewise functions there, which ends up just being the original absolute value function. So if I wanted to sketch that, this is what I would have. And so I can see what happens to this function as x approaches 0 from the left-hand side of x squared divided by the square root of x. That's going to be 0. It gets closer and closer to 0. And what happens as x approaches 0 from the right-hand side, I'm going to have x squared over the square root of x, or the absolute value of x. That's also going to approach 0. And so because the left-hand limit equals the right-hand limit, we can say that the limit as x approaches 0 of x squared divided by the absolute value of x is equal to 0.